All right, welcome to Algebra 2. We're gonna go ahead and get started. Here is lesson 72. We're gonna learn about logarithms. The basic concept of logarithms, what we learned before, is when you have in this format, this is just a regular form. They want an exponential form, and that means your base now becomes your main base here. Your solution becomes your exponent, and your x becomes your solution here. Same thing with the natural log. We're not going to touch that much here. But here, the natural log of x is equal to y. To put this, the natural log in exponential form, we would have your e. We're going to change it now because natural log and e, they go hand in hand. To the solution, that's your exponent, is equal to x. So here we're going to learn about different properties using those logarithms. They use this all the time for calculus. Here we're going to learn about the inverse log. What this means is b to the, and this is the exponent, log base b to the x power. If your bases are the same, so the number here and the base for the log for your exponent is there, that means they cancel out and you're left with just the x there from there. Here, or another way to have it, log base b of b. So the two numbers, they're right next to each other. So log base 3 of 3 to the x power, these cancel out and you're just left with an x. And also for this, the natural log of e to the x power, natural log and e, they cancel out and you're left with your exponent, and that would be your solution. So you're going to use that later on here. Example 1, we're going to start simplifying using the inverse log. There are 1, 2, 3, 4, 5 different properties that you will learn. If you need to screenshot each of them or just to get a clearer picture, you may do so. I would recommend it. But example 1, you're simplifying the log base 5 of 5 to the 2c plus 3 power. If you notice, the key thing here is they're right next to the base and the same number, they're right next to each other. They are exactly the same. That means this cancels out and all you're left is the exponent, 2c plus 3, and that's your answer. Next one, 2 to the log base 2 of p. Now this is your exponent. Your base from your logarithm here and your regular number here, they're exactly the same. So therefore they cancel out and you're left with a p for an answer. So just see the common numbers, if they have the same number, they cancel out. Here, to change your base, if you notice for your calculator, you cannot do these problems in your calculator because this logarithm here, the one that show and pop up in your calculator, this one right there, where my pretty fingers are, there, that log is considered the natural log. So log base 10. And here, if you notice, for all of these, you're dealing with log base 4, log base 5, log base 7. You can't do any of that in the calculator. So they call this the changing base, meaning you can change it, you can convert it, you can get a number if you put it in terms of this here. So to do this, it's very simple. You have your base number, so log base b of x. To change it, all you do is you divide the log of x, so log of your main number there, and it's going to be base 10, so you're not going to do anything to the bases, divided by the log of your base that you started with. So when you divide those two numbers, you're going to end up with the logarithm answer. So example 2, evaluate log base 4 of 8. So let's go ahead and start putting this in terms of the common log, which is log base 10, and get an actual answer. So log base 4 of 8, you're dividing by both logs. So you can go ahead and write that first. Here, you're dividing the regular log. You're not looking for the bigger number. You're always looking for that main number here. So that's your main factor. I'm not calling that a base because the small number is considered your base. So it's log of your main number here divided by log of your base. Your base is always that sub number. It's not the exponent, it's like the sub number. So you have log of 8 divided by log of 4. You're not moving anything. You're not doing anything with the bases. I know the book has it where they have different A's and B's for answers, but you don't need that. Now, log of 8, if you put it in your calculator, all you have to do is log 8. You end up with an answer of 0.903. And then log of 4 is 0.602. I would recommend you writing it down before you divide, because what I did is I did log 8 divided by log 4, and my decimals were pretty off. They weren't off by much, but they were pretty off. So for your answers on your book, they would prefer this method. Now you have 0.903 divided by 0.602, and you end up with about 1.5. And that's your answer for it, this one. Another way, and this is what we do a lot in pre-calculus, so we have a log base 4 of 8, same one. but we can do it in terms of natural log. The natural log is considered the ln button there, and that's what you see right there, ln. So if you do ln, so same thing, you're dividing. Instead of log, you're just doing natural log. So natural log of your main number, which is 8, divided by a natural log of your base, which is 4. You end up with 2.079 for natural log of 8, and you end up with 1.386. All I'm doing is entering them in the calculator and putting the first 3. Now I have this. If I were to divide these two, I still end up with the same thing as 1.5, etc., etc. I just round it. Product property. So now we're dealing with logarithms. It gets more complicated. They turn into equations. When they do turn into equations, we have log base b of mn. That means they're multiplying two numbers. So whether it's factors, whether it's xy, that means x times y. So when they're multiplying, they're adding. And later on you see when they're dividing, they are subtracting. So for logarithms, multiplication and addition, they go very much so hand in hand. Now, here, they want us to solve for log base 3 of 63. Using the log base 3 of 7 is equal to this number. That means we have 63, so that's like our mn. We're going to go ahead and find factors of 63 that we can use. Here, they already gave us one factor that they want us to use. They said to use log base 3 of 7. They want us to use a 7. So 63, factors of 63 is 7 and 9. So it's not just any factors. They give you one factors to help you out. So here, the log base 3 of 63 is equal to log base 3 of 7 plus log base 3 of 9. So now, 7 plus 9, in terms, if they're adding, that means they're actually multiplying, so it's 7 times 9, and that gives you your 63. But if you look here, they have the log, the base of 3. We can convert this 9 and convert it in terms of a 3. So we can, what did I put here? Put it in terms of the same base. So we have to think outside our box. Here for 7, factors of 7, you can't find anything else for 7. So it's going to be log base 3 of 7. But here for the 9, we can have it in terms of log base 3 of 3 if we just square. So we're going to kind of undo it so they can have the same exact base. So here, the 9 can be converted, if we're looking at the base, it can be put in terms of 3. So when we put it in terms of 3, we remember the rule from the first one here, the inverse log. If they have the base and the number, if they're exactly the same, and they're side by side, they can cancel out. So now I have log base 3 of 7 plus, and I'm left with my 2. We're always finding different ways of simplifying. There's different ways for every one of these steps, but just take it step by step and understanding all of these rules. Now, if you look here, here says log base 3 of 7 is equal to this number here. They gave us what log base 3 of 7 is. So in place of log base 3 of 7, I'm putting 1.7712 plus 2. And then I solve. And in this case, I get 3.7712. And that's my answer there. B. So we're dealing with the product property. Log base or log 60, the base is 10. If it doesn't show you a base, the base is always 10. That's considered the common log. So here it says use log of 6 is equal to this. So we're dealing with terms of product property. That means we're looking for two factors or factors of 60. They already gave us one. They want us to use 6. So 6 times what gives you 60? And that would be 10. So that means for log of 60, if we want to kind of undo it and put it in additional terms, a sum, we can do log of 6 plus the log of 10. So now we have these two properties. We found two factors. When they're multiplying, you make them add. So they're multiplying, we make them add. So 6 and 10, 6 times 10 gives you 60, but in logarithm form, you have to make sure they're adding. Now, remember what I told you. These are all the common log, meaning log base 10. If we look at the log of 6, they gave us what the log of 6 already is. The log of 6 is 0.7782. Here it says plus the log of 10. The common log, their base is 10. And then it says of 10. The numbers are right next to each other. They cancel out. When they cancel out, it doesn't turn into 0. It turns into 1. So therefore, we add all the numbers. We get 1.7782. Or you can simplify it. I just put it in terms of that. To check your answer, to see if you're doing it right, all we have to do is just the change of base. So let's grab a nominal number, log of 60. Log of 60, you can actually put that in your calculator, and you end up with 1.7782. If I were 1.7782, so if you use that in your calculator, you can go ahead and already solve for it. Or up here, example 3, log of 63. Gonna do it right here. So to check it, so you want to check your answer for log base 3 of 63, log base 3 of 63. We can do the change of base method, meaning we're dividing the log by the other log. Log of the main number, which is 63, divided by the log of 3. So remember, just like how you did here, you divide and get your numbers, decimals, and then you divide again. So if I do all of that for A, I end up with the same exact answer, which is 3.7712. So that's a great way to check your answers. Let's see how long this video is. We're gonna make a part 2 because I can't make these videos too long. They won't let me load in YouTube. So go ahead and watch the second part.